Hey everyone, how's it going? I'm Shahab and welcome back to our series From Maps to AI Agents. In the previous video, you learned how you can use the Vercel AI SDK to create a very basic AI chatbot, one that you can communicate with, send some images, and then receive some responses. And then this AI chatbot can also store the history of the messages, and then it can remember all the previous messages in that chat session. So it's still very basic, but in this video, we are going to add more capabilities to our AI chatbot. And what's going to happen is that if you remember in the previous videos, we implemented some very basic geospatial tools, and now we want our chatbot to have access to those geospatial tools. And then based on some of the requests that the user sent to the message, the AI chatbot is able to call or execute those corresponding functions. But let's see how this works before we jump into the code, and then you'll see how much powerful this could be in the future when we add more capabilities to it. So as you can see in here, we again have the same UI as before, but the underlying things have changed. Let me open up our chatbot, and then let me just draw a polygon somewhere, and then I just ask it what is the area of this polygon. Okay, so what happens is that it now grabs the polygon, and then it runs or executes the corresponding function. In this case, it runs the calculate area function, and then it gives us the area of that polygon in square meters in this case. So let's validate that. So we also run it, and then yes, we get in this case the units are different, square kilometers, same as what we get in here, which is in square meters. Or I can also ask it what is the centroid, hopefully centroid of this polygon. So this is also the latitude and longitude, or longitude and latitude of this polygon, and then we can also validate that 83 looks good, correct. So what happens again is that based on the question that I ask it, it knows what tool would be related to that question or that query in general, and then it will run that based on my query, and it uses the information from the drawing on the map, and then it will run the corresponding function. So this is what we are going to do in this video, but let's see what happens also in action. We have a polygon in here, and then we draw this polygon, let's say polygon, then the polygon has just some vertices, and then the vertices are extracted from here and here and here as GeoJSON, and this information which is GeoJSON goes to the something that we call a store, where it actually, the store is nothing but something that stores the information or the GeoJSON information about that polygon. Then we send the or not from here, but then the user sends the message, user's message, okay, or query. And then what happens is that the AI model, or LLM in this case, it will go through all the list of all tools, and then it finds the one that relates to the query that the user asks here, and then run it. And then finally, the AI model, again from here, returns here returns the results, so results of the tool calling. Okay, so this is what happens. So a very simple workflow, starting from a drawing on the map, the vertices, the GeoJSON created, and then the GeoJSON that is stored in something called a store or a variable, as we will see, and then the user message that is connected with that query or that stored polygon in this case, and then the corresponding tool is run, and then the results will be returned to the user. Let's see what are the components that we need for this new feature in our app. The first thing, if you remember, is to somehow store the polygon or the GeoJSON that we get from the polygon that the user creates on the map. And we want this information to be available global or application-wide for different parts of the app. And the reason for that is if we define it locally in a single file and other files can't access it, it would be difficult for our chatbot to do any analysis on that GeoJSON file. Because we have to pass the local variable to different components, and it will be very error prone, and we're not going to do that. So for that, we need to have a global state management system. And for this, I use Zustent. I personally use it frequently in my projects. It's very lightweight and fast. So we import the create function or the create method in Zustent to define our store, and then we need the two types, feature and geometry, from the GeoJSON because we are using TypeScript, and it's very important to define or use types to lower or minimize the likelihood of making type errors. So we define our store, we have a getter, we have a setter for storing the drawn features, and that's it. So we have the store defined, and now let's use it. So we created the draw store in a new path. We defined a new feature map draw, and then under it we defined a folder called store, and then inside it we created the draw dash store. So let's see how this can be used. In use map draw that we created in one of the previous videos that handles all the drawings and things like that in our app, now we import the storage that we created. So we import it in here, and then we extract the setter or set drawn feature, because now what we want to do is that when the user creates a drawing on the map, we want to set the or assign the GeoJSON information of that polygon to the store. And this is what exactly we do in here. So we use the set drawn feature, which is the setter, and then this is the handler that handles all the drawings that the user creates on the map. So whenever that the user draws something, this handler is called, and then we make sure that the drawing is valid. And then if it's valid, we extract it in here. It's in GeoJSON format already. And then we set the drawn feature based on this GeoJSON information that we extracted. So this is what is available through the map library GL, and it's automatically already in a GeoJSON format. So that's how it works. Now let's go to the other component that we need to change, and that's the AI chat. This is where the interface, the main interface of our AI chatbot is located. And there are two things that we need to change in here. The first thing is to call the store, the Zustent store, and this time we extract the latest value of the drawn feature. What does it mean? It means that if I go to the app, so you see that when I draw something here, I want the latest version of this. If I draw something else somewhere else, I want this to be updated. So it always gives me the latest version or the latest information about the polygon drawn on the map. And then I want to send it to the backend. What's the backend? If you remember, in the previous video, we created an API route that hosts the backend information about our model. All the main workflows of the model handling things and applying or creating the messages that the LLM generates. All these things happen in here in the backend. Because we need to send this information to the backend, we have to define a body. It's just like a very normal way that you want to post something to the backend, an HTTP method. And for that, you define a body. And in our body, we have the drawn feature, the GeoJSON information. And we want to send the GeoJSON information to the backend so the LLM can use this information to calculate, for example, the area or calculate the centroid of the polygon. Okay, so it needs this information. And we need to make it a string. So we have to convert it to a string to be able to send it to the backend. And we now also have a new property here, and it's called max steps. And this is actually the maximum number of tools or exchanges that you can have with the model in each run. What does it mean? For example, you have a tool that calculates the area for you for a polygon. Then you ask the model, hey, I want the area to be calculated for this polygon. What the model does is that it calculates the area and it returns the results. So if by default this is 1, it only returns the results and it doesn't provide any text for you. It just gives you the results returned from the calculate area function. However, if it's 2, it also gives you something like a confirmation or information about the results. For example, it says that, okay, I calculated it and this is what I get. And this is exactly what happens in here. So in here, if the max steps was 1, I never got this. Things happen in the background. But now that I have the max step greater than 2 or 1, it now also gives me this text. Okay. Another scenario is that, for example, you may have multiple tools that are going to be run one after another, and if it's 1, only one of them will be run. So that's important to assign a good number to this max steps depending on your application. So we don't need to change anything else in here, and then let's go to the backend, to our API route. Okay, so in this file in our backend, we have a couple of new things. The first thing is that we need to get the drawn feature that we sent from the client side. And then we just call it drawn feature string because it's actually basically a string. It's not a GeoJSON. And here we just parse it as a GeoJSON. We convert it from a string to GeoJSON. And we do 2 new things here. The first thing is that we need to give the LLM some context about the question or the query the user provides. If there is, for example, a tool to be called by the LLM. So as an example, the user says that I want you to calculate the area of this polygon. So we need to, before that, give the LLM some context. What do we mean, or what does the user mean by this polygon? So for that, we need to synthesize a user message in the backend. There are different ways that you can handle this, but this is perhaps one of the simplest of all. And for that, we create something called a feature context message. It has a core message type. The core message type comes from the Vercel AI SDK. it has this structure. It has a role. The role could be user, assistant, or tool, and the content is the text that this carries. And in this case, we just say that, hey, the user has drawn or selected the following GeoJSON feature on the map, and then we also include the string of the GeoJSON information of that polygon drawn. So that's very simple. So we synthesize a user message to be used as a context for our LLM. And now we need to include this context to the history of our messages, or the messages that we're going to send to the model. And for that, we do something like this. So if you assume that this is a history of messages, okay, the history of messages, maybe I need to comment this to be able to. The history of messages starts from 1 to n, okay, so or 0 to n, and this is the total number of messages exchanged between the user and the LLM, okay? And then now when we want to incorporate this context message, we want to do something like this. So we want to say from message 1 to n minus 1, okay? This is one piece. And now my context message, and now the last message, okay, or maybe this. So this is now the structure of my new message or message history. Okay, so the first part is everything except the last message, then the context message, and then the last message. So everything until the last assistant message, and then the last message, which is the user message, and before that is another user message, which is our context. Okay, so that's very simple. As an example, if the user has asked, hey, I want the information or the area of this polygon, this is that message. And then before that, we put this to give the LLM some context about what it's going to do. So that's what happens in here. So let me get rid of this one. And then again, we have the max steps defined in here. There is a slight difference between the max steps that we define or we set in the backend and the front end. I will talk about that, but for now, let's use the same max steps in here. And another thing that we need to set is the tools. So this is actually, there are the tools that you will see, and these are the tools that the model has access to and will execute them based on the query the user provides. So we have the geospatial tools, but where are these geospatial tools are defined? In here. So under the lib tools.ts, you can find the geospatial tools that we have. Let's first go to the tools that we create in here. We have two tools for polygons. We have the calculate polygon area tool, and we have the calculate centroid tool. And if you open them, you see that we actually reuse what we created before in one of the previous videos. These are actually the turf functions that we created, if you remember, for calculating area, for calculating the centroid. So we are reusing the same functions in here, but with a slight difference. We also need have a tool method in here that actually creates a tool for the LLM, and this comes from the Vercel AI SDK. Whenever that you want to create or define a tool for your LLM to have access to, you need to create it like this. Defining a tool needs a description, which means what is this tool? So this description is like a context for the model, for the LLM. Okay, so it sees this and then it knows that, hey, oh, I understand. Now this is for this. And then what are the parameters of this function? So we know that this is a polygon and JSON information, and then we have to create an object that contains the parameters of our argument to this function. And we use Zod for validation. So you define a schema for your parameters to make sure that the model doesn't generate something that may not be meeting the requirements of your parameters. For example, if the parameter has a type of a string, you want it to be a string. You don't want it to be an integer or a number. So Zod actually restricts the type of the arguments or parameters generated by the model. Okay. So we also, for the polygon, it has a polygon feature schema. It's actually the GeoJSON type of polygon created. So we need to define it in here. So the schema of the GeoJSON. And if you know, a GeoJSON it's like this. It has a type, for example, it has properties, geometry. So this is actually a valid GeoJSON, and also has coordinates. So it has a type, okay, it has a property. Property could be just empty, or you can just remove it, it's not important. It has a geometry that shows what is the type of the geometry. It could be a polygon, it could be a line or point, and then the coordinates. In this example, I think that it's very visible that the last and the first and the last coordinates inside the geometry should be the same for polygon, because we want to make sure that the polygon is closed. Okay, so this is the structure of the polygon that should be defined in these schemas. You see that we have the properties schema that is for the property. We have the position schema, which is actually the coordinates. And then here we just put everything that we define in here and define our polygon feature object schema. Okay, so the type, so this is the GeoJSON object schema, the type, the properties, the geometry, the coordinates, everything that you can see in here. We need to create a schema to validate the type for the GeoJSON. So in fact, the tool that you define, the tool itself has a description, what the tool is, what it does for the model. And then each parameter also itself has a description, just like what you see in here. So these descriptions help the model to prepare the parameters and then execute the function correctly. And then after getting the polygon information in the right format from the tool, we just pass it to the calculate polygon area, and then it returns the area. So simple. And all these things are same for the Centauri tool. And then we export both of these tools from this tools file, and that's what makes our geospatial tools that you've seen here. Yeah, so it was everything that we wanted to walk through in this video. There are a lot of other things that we are going to add. If you need more detailed videos, or if you think that you need more information, let me know. I will go through some of the things in more detail. But I hope that you enjoyed this video. Make sure to subscribe and follow the next videos that we're gonna post soon. Have a great day. Take care. Bye-bye.